Sadly.
Hi YouTube. In this schematic setup I made up a relay, a simple relay with a start and stop button. In the industry these are called often contactors. The beauty of a contactor is you can switch with a small current, small control current, often also at a different voltage. You can control a large current, a very powerful device, big motors, or cut. The main reason I made it is I had quite a few requests from some of my subscribers how I made my control box, which features in quite a few of my other videos, and it's basically a principle like this. I'll provide a schematic how this is connected, because an important thing is that control wires are separated from the load carrying wires. This particular relay got 3 contacts in parallel on both sides, so it gives me a larger current capacity. The relay is rated at 25 amp per phase, so technically I could push 75 amps for here. This is only 4 mil, so I should put say 10 mil wire in there, 16 mil to have that current, but not required in this particular case. The control wire goes on terminal 4, that's a spare normally open terminal, goes through the on button. And the on button gets a supply from the phase, so it's a latching contact, so it's energized and it will latch itself. Push this, it makes, energy goes through the jumper. This is the off button, but goes through the jumper and drives the coil. The actual on button is a normally open contact, the off button is a normally closed contact, so power goes in, I make. Relay gets energized through here, that contact is closed, drives the relay coil, pulls the relay in, stays on. Touch this button, off, relay falls out, load lamp is off. The schematic will be attached, phase, neutral, main current in through the relay, in the yellow wire out to the load. In this case it's a neon lamp, black is neutral, return path for the circuit. My incoming supply is brown phase, and light blue is a neutral. Okay viewers, I've connected the voltmeter on the supply, 237 volts, and a milliammeter in series is the relay. I'll close the relay and we got 27 milliampere, 28 milliamperes controlling the coil which pulls the contact wedge in, and that switches the load. Now I can connect up a 12-13 amp load and we'll see what happens. Viewers, I connected the ammeter on the circuit for my load and we're going to turn that on briefly. Drawing about 20 amps here. We still got the coil 23 milliamps, so because the voltage has dropped a bit because my lead is a bit thin. But so we say the relay coil 23 milliampere, 20 amps. Through the ammeter, into the heating elements which are laying out here, and they're glowing bright orange at the moment. So as you see, my voltage has dropped a little bit. Voltage is 219 volts at the moment. Heating off, this voltage will rise soon. It goes back to 237, so my lead is quite long, so 20 amps is quite a bit of standing load. Thanks for watching at this stage. I'll post the schematic at this video at the same time. Relays come in different sizes and shapes, so are kits. This is a small 12 volt relay, switches about 8 amps. It's a 24 volt relay. This is an octal relay, common used in switchboard panels. We have a bigger relay here that's 400 volts, 460 is about 80 amps per phase. It's not a big relay. And we have the real tiny relays. This I have found in alarm panels. Schematic will follow. Our cats are electrically minded. Eyelash, panel and schematic. Okay, here's the schematic for the push button relay contactor. Phase on top, neutral. I've wired it up exactly the same as in the hardwired thing. That's the relay. It's a 4-pole, 1, 2, 3, 4. Push button 1, that's normally closed, that's for the off position, and push button 2 is normally open, and that's for closing the relay into the supply. And then the load is connected onto these two terminals, to this orange strip connector where the lamp or the heater was connected to. I nearly forget, it's very important that the push button has its own separated supply or its own separate contact on the relay, as otherwise the push buttons could carry the load current, which we don't want, and the buttons would melt out. So there needed to be a spare terminal on the relay for the actual switching for the push buttons, which only controls basically the relay current, which was between 23 and 28 milliamps. Finish off this video with a beautiful sunset over the Waitakere.